Hello students, in today's lecture we will discuss 2 or 3 more theories which are very important from the topic point of view, and then after we will see the list of formula of different objects. So let us start today's lecture. In today's lecture our first theory is state and prove parallel axis theorem. Now what is parallel axis theorem? When two axes are parallel to each other, then what is the relation between moment of inertia about these two axes? It is known as parallel axis theorem. Let us see the statement first and then after derive its formula. What is the statement actually? If Ig is the moment of inertia of a plane area. Remember this, here it is Ig. So Ig is the moment of inertia of a plane area about an axis passing through its center of gravity. So G means what? G means center of gravity, and Ig means moment of inertia about an axis passes through the center of gravity of particular area. Then what is given? Moment of inertia of the area about axis AB means IAB, which is parallel to the first axis. Which is parallel to the first axis means what? IAB and IG. Ig is the first axis and IAB is the second axis. So these two axes are parallel to each other. It is given actually in the statement. Now what happens? Then at a distance h from center of gravity is given by this formula. So is given by this formula means what is the formula? IAB is equal to Ig plus AH square. So actually this is the relation which we are going to derive. Now furthermore, what are the notations denotes? IAB is equal to moment of inertia about axis AB. Ig is equal to moment of inertia about CG. A means what? Area of the particularly given section. H is equal to distance between CG of section and axis AB. Okay, so H is the distance between two parallel axes, you can say. Now actually we have to derive this formula. We have to prove this formula. IAB is equal to Ig plus AH square. So let us start the proof. Here you can see this is the figure in which first axis is this x-axis, you can see over here. It is the centroidal axis of this lamina having area A. It is the centroidal axis of this particular lamina. And second axis is given to you is axis AB, which is over here. Now these two axes are parallel to each other, and the distance, vertical distance between these two axes is given as h. Okay, so h is the perpendicular distance between two parallel axes. Now again discussing that, this is the particular CG of the lamina. Now as earlier in the center of gravity chapter, we are cutting a small elemental strip having area dA. This is the small elemental strip having area dA. Okay, consider the shape of the strip as a rectangle like this. This is this rectangular strip, small. Now what is the distance? The distance between strip and the centroidal axis is y. You can see over here in the figure. So this is the main important thing regarding the figure. Now let us start the proof. What is given in the proof? Consider a small elemental strip of area dA. Y equal to distance of strip of the strip from the CG of the section. Now what is moment of inertia? Moment of inertia, let us take first the moment of inertia of strip about CG of the section. Now what type of strip is this? Strip is rectangle, but actually strip is having area dA. So according to the definition of moment of inertia, I is given by area dA into square of the distance. Square of the distance y, because y is the distance from this x-axis of the particular strip. So moment of inertia of this strip is given by I is equal to dA into y square. Now moment of inertia of the whole section we have to find, but this is only the moment of inertia of small particular rectangular strip. We have to discuss about the whole section. Then what is about the whole section? Then we have to find Ig of total area, which is equal to sigma dA into y square. Now what is sigma dA? Sigma dA means summation of all such areas of different strips is equal to sigma dA. Into y square means the distance, square of the distances from particular strip to the main CG of the lamina. Okay, again repeating, what is y? It is the distance of the particular strip from the CG of the lamina. Now let us go ahead. For deriving the moment of inertia, we have to integrate this formula, because this is the formula of particular strip. We have to integrate this formula like this. You can see moment of inertia of whole section about the axis AB. So according to furthermore definition, IAB is equal to sigma dA, means area of all strips, into square of the distance. Now what is the square of the distance? How this h plus y is coming? You can see in the previous figure. What is h plus y? You can see h is the vertical distance between two axes and y is the distance from strip to the centroidal axis. So we are taking now addition of these two, h plus y, means we are taking moment of inertia about this axis AB. So we have to take distance of this strip from strip to the axis AB, means it is h plus y. Okay, so that's why we are taking square of the distance h plus y. So it is sigma dA into h plus y whole square, IAB equal to. Now simplifying sigma dA as it is, expand h plus y whole square, which is equal to h square plus 2hy plus y square. Multiply sigma dA inside, so it will give you sigma h square into dA plus 2hy dA addition plus sigma y square into dA. Now solving these three terms separately. Now this is sigma h square into dA. Now sigma dA, what is sigma into dA means? Sigma into dA means total A, means total area of the lamina, sigma into dA. H square will be as it is because h is constant distance. Now this middle term becomes 0. How it becomes 0? We will discuss it later. Now again, this is the definition of moment of inertia. Sigma dA means area into square of the distance, which is Ig actually as per the definition earlier. So final answer will be IAB is equal to Ig plus AH square. Okay, Ig plus AH square as per the formula. So this is the simplification of parallel axis theorem, IAB equal to Ig plus AH square. This formula we will use in each and every numericals. Okay, so remember this formula. This is very must and very most important formula. IAB means what? Moment of inertia about any particular axis. Ig means what? Moment of inertia of about centroidal axis, which is parallel to the axis AB. Okay, so centroidal axis must be parallel to axis AB. Now how middle term becomes 0? Let us see. This middle term sigma 2hy into dA becomes 0. Let us see how. Furthermore, here reason is given. First term sigma h square dA is equal to A into h square. Sigma y square dA is equal to Ig as per the formula in the previous page. Now sigma dA into y, 2h will be constant. Okay, sigma dA into y means what? Sigma dA means area, and y means what? It becomes y bar. How? For suppose for the particular small strip, the distance of CG is y. For the second strip, the distance of CG is again y2 suppose. For the third strip, distance of CG is y3 from the centroidal axis. So adding all the distances, we can find a1 plus a1y1 plus a2y2 plus a3y3 as per the method of CG. It will become y bar. So y bar is exactly at the centroid of the particular lamina. Okay, so distance of that y bar from the centroidal axis will become 0. Actually this is the very tough funda. If you are facing the difficulty in this, you have to contact me personally, because y bar equal to 0, the middle term becomes 0. Actually you will not get this y bar equal to 0 surely via this method. So you can contact me for the queries. So now finally you just remember this thing, IAB equal to Ig plus AH square. This is known as parallel axis theorem. So this is very most important theory, has been asked in the JTU at approximately 5 to 10 times. Now let us discuss about the second theory, which is state and prove perpendicular axis theorem. You can see in the figure there are three axes given to you. First axis is x-axis like this. Second axis is y-axis, which is actually perpendicular, but both axes are horizontal right now. Like this is x-axis, this is x-axis and this is y-axis, okay, like this on the paper, on the plane of the paper, and perpendicular to that, perpendicular to this both axes, vertical axis is given to you, that is z-axis. Now here small elemental area dA is placed. There are three distances from three axes of this area. Y is the distance, perpendicular distance from x-axis, x is perpendicular distance from y-axis, and r is the distance from origin. You can see r is the distance also from z-axis. Now what is the statement gives? If Ixx and Iyy be the moment of inertia of a plane section about two perpendicular axes meeting at origin, means Ixx and Iyy are moment of inertia of two orthogonal axes, then Izz about the zz axis perpendicular to the plane and passing through the intersection of xx and yy axis is given by Izz equal to Ixx plus Iyy. What it means? Moment of inertia about this axis is equal to addition of moment of inertia about x-axis and moment of inertia about y-axis. Now you can see from the figure that using Pythagoras theorem, you can see just in the figure, using Pythagoras theorem you can see x square plus y square is equal to r square, because this triangle, if you make this triangle vertical, then it will become like this, vertical right angle triangle. This is x, means base, this distance, and this particular distance becomes y, because this is y, then this is also parallel line becomes y, and the hypotenuse will become r, which is over here r. So by Pythagoras theorem you can say x square plus y square equal to r square. We will check this x square plus y square equal to r square in the theory ahead. Let us see the proof of this theory. Consider a small lamina P of area dA. Okay, x and y are the coordinates of P along OX and OY axis, OP equal to R. All the things are given in the figure itself. Now, R square is equal to x square plus y square. R square equal to x square plus y square. Now, Ixx, what is Ixx? According to the definition, it is moment of inertia about x-axis, which gives area into square of the distance. So, area will be dA and square of the distance means y square. Similarly, Iyy equal to dA into x square, because area of distance of this area dA from y-axis will be x, and Izz equal to dA into r square, means area dA and distance will be r. So these three formulas, which three formulas? Ixx, Iyy and Izz are as per the definitions. Now let us simplify Izz. Then what happens? Izz equal to dA into r square. dA will be as it is. Now as per earlier calculation, Pythagoras theorem, r square equal to x square plus y square. So it will give you dA into x square and dA into y square. Now first box will give you Ixx and second box will give you Iyy. So this is the very simple proof of the perpendicular axis theorem. Izz equal to Ixx plus Iyy. So these are the two theories, very most important, parallel axis theorem and perpendicular axis theorem. Now let us derive the third theory, which is find the second moment of area of a circular lamina about its centroidal axis. Okay, so basically we have to derive the formula for circular plate. You can see in the figure here, this is the circular plate as shown in the figure. Now circular plate is symmetrical to both x-axis and y-axis. So moment of inertia of this plate about both axes, Ixx and Iyy, will give the same answer. Let us check. From the origin at a distance r, or you can see at a radius r, r is the total radius of the circle. From the origin at a distance x, we are cutting a circular strip like this, circular ring like this. It is a solid ring, but inside area is hollow. So we are cutting the ring of thickness dx as shown in the figure. Now, if you are cutting the strip, then if you are unwounding, cut the strip over here and then open the strip like this. Okay, in the earlier situation, the strip is circular, but if you cut at certain point and then unwound the strip, then it will become a rectangular strip like this. Cut from here and open the strip, then it will look like this. Okay, then this is the thickness of the strip dx, and this is the length of the rectangular strip, which is earlier circle. So this length is equal to circumference of the strip, means 2 pi into x, because circumference means 2 pi into radius. So radius of this strip is equal to x. So what is the area of this rectangular strip? What is the area of this rectangular strip is equal to dx into 2 pi x. So here it is written that area of the strip is equal to 2 pi x into dx. So hope you are clear with the area of this strip. Now what is moment of inertia of the ring about zz axis? Okay, so about zz axis means in the perpendicular axis theorem, moment of inertia equal to area m2 square of the distance. So what is the area of the strip? 2 pi x into dx. So area is equal to 2 pi x into dx. What is square of the distance? It is x square. So by multiplying and by simplifying, you will get 2 pi x cube into dx. So this is the moment of inertia of the ring about zz axis. Okay, now let us go ahead. If you want to find the moment of inertia of total circle, then integrate it from 0 to r, because strip can be cut from center up to the end of the circle, up to the circumference of the circle. By simplifying, Izz is known as polar moment of inertia. By simplifying, 2 pi will be constant out from this, and integration of x cube will be x raised to 4 by 4 limit 0 to r. So you can replace r in place of x. So 2 pi into r raised to 4 by 4 means pi r raised to 4 by 2. If you convert radius into diameter, then r equal to d by 2 whole raised to 4. So simplification will give pi by 32 d raised to 4. So it will be Izz. Now as per perpendicular axis theorem, Izz equal to Ixx plus Iyy, but Ixx equal to Iyy. As I said, it is symmetrical to both axes. Circle is symmetrical to both axes, so both moment of inertia must be equal. So now Izz equal to, you can say, 2 times Ixx. Now what is Izz? It is over here, pi by 32 d raised to 4. So Izz equal to pi by 32 d raised to 4, 2 times Ixx. Replace 2 in the division in the left side. So Ixx will give you the answer pi by 64 d raised to 4. And similarly Iyy is also same, pi by 64 d raised to 4. So hence we are getting the formula of the circle. Moment of inertia of the circle will now given by pi by 64 d raised to 4. So this is the third theory, means the derivation of the formula of the circle. Let us now go ahead. We will check some formulas. You can see this is the formula of shape, area, and according to that moment of inertia will be given to you. First shape is rectangle. You can say this is the CG of the rectangle. Horizontal width of the rectangle is b. Vertical depth of the rectangle is d. Then area will be b into d. Moment of inertia about this x-axis, horizontal centroidal axis, will be bd cubed by 12 as per the derivation in the previous lectures. And moment of inertia about vertical centroidal axis will be db cubed by 12. Okay? Because rectangle, while considering x-axis, rectangle will be like this. While considering y-axis, rectangle will be vertical like this. So b will become horizontal and d will become vertical. So in short, when the rectangle is changing the position from vertical to horizontal, the dimensions are interchanging. Means b replaced by d and d is replaced by b. So you just have to remember this formula. For the circle, just we have derived area is equal to pi by 4 d square or pi r square also. Moment of inertia about both the axes will be same, pi by 64 d raised to 4. So these are the formulas for rectangle and circle. What is for the triangle? For the triangle, the base will be b and the height will be h. So moment of inertia, area is given by 1/2 bh. Moment of inertia about centroidal axis will be bh cubed by 36. About yy axis will be reverse hb cubed by 48. But this formula we will not use anytime. And about base, if you find moment of inertia about this base, then it will be bh cubed by 12, which we have derived earlier in the previous lecture. You can go through my previous lectures also. So these are the list of the formulas. So friends, we are concluding this lecture at here. 3 theories are completed: parallel axis theorem, perpendicular axis theorem, formula for the circular area, and list of the formulas. In the next lecture, we will solve some numericals and we will conclude this topic. So thank you very much. Till then, go through this video and solve all the theories. Thank you.